Okay, folks, I'm going to go over the free response questions from the test because I just want to kind of share some ideas with you about what I saw and how we can kind of improve. So here's one of the first ones. It basically asks you to find the limit as x approaches -1 of this function twice f of x times cosine pi x. So the first thing that you need to realize is this is one of those ones where our properties, we can actually break it into two pieces. We can say the limit as x approaches -1 of twice f of x times the limit as x approaches -1 of cosine pi x, using that the limit of a product is equal to the product of the limits. And realistically, if I even wanted to take it one step further, I could do this: the limit as x approaches -1 of 2 times the limit as x approaches -1 of f of x times the limit as x approaches -1 of cosine pi x. And the first rule should be, you should just try substituting. So we can go through and say that the limit of a constant is equal to the constant. So this first piece would definitely be a 2. Okay, so that would be this piece right here would simplify to 2. The limit of f of x, if we stick -1, and what I told you is let's check it in the denominator first. So I'm not even going to factor yet. What I'm going to just do is go right to the denominator and see what happens when I plug in that -1. So I'll do -1 squared minus -1 minus 12. And when I go to simplify that expression, that piece right there, I'm going to get 1 plus 1, 2 minus 12. That's going to give me a -10 down below. So this tells me I can actually do a substitution. So now I'm going to substitute the -1 up top. I'm going to do twice -1 squared plus 7 times -1 plus 3. -1 squared is 1, 2 times 1, 2. 2 minus 7 plus 3 is going to give me -2. So that's -2/10, which is basically positive 1/5. So this guy right here becomes positive 1/5. And then here comes the big thing. What I saw a lot of was this. I saw a lot of cosine negative pi. That's what I saw. That's what I saw. Well, I'm going to tell you folks, when we deal with this, we can't live trig this. We got to simplify trig. And what happens is cosine of negative pi actually simplifies to -1. So this becomes 2 times 1/5 times -1. And technically, I could leave it there, but the answer that is in its simplest form is -2/5. So that one's -2/5. Okay. Now the vertical asymptotes. Let's talk about the vertical asymptotes because this is where I saw a lot of challenge. Remember, we're trying to find the vertical asymptotes of f of x, where it's 2x squared plus 7x plus 3 over x squared minus x minus 12. So for vertical asymptotes, it's what makes the denominator 0, but doesn't zero out the numerator. But that's not the answer in calculus. I got to prove it by limits. So the first thing I need to do is I need to try and identify where I see the vertical asymptotes. So what I'm going to do is factor the numerator and the denominator. And most of you are able to factor the numerator and the denominator, and you got x minus 4 times x plus 3 in the denominator. You got, sorry, 2x minus 1. I'm sorry, 2x plus 1 times x plus 3. So what ends up happening here is this is our factored form of f of x. And you notice the x plus 3's cancel out. What that tells me is there is a hole at x equals -3. So I'm not going to investigate that. There's a hole there. I'm going to leave that alone. That's not a vertical asymptote. That is kind of like where, the curve goes like this, and then there's a hole, and then it keeps going like that. Well, what I need to do is I need to investigate. And it's not that, oh, well, 4 makes the denominator 0, therefore it's a vertical asymptote. That's algebra 2. That's pre-calc. That's not calculus. What I need to do is I need to investigate the following too. I need to take a look at x approaching 4 from the left. I need to take a look at x approaching 4 from the right of those two functions. What I need to do is I need to see if infinities come up as my answer. So what I need to do is I need to say, what is going to happen when I'm looking at this limit of f of x as x approaches 4 from the left and as x approaches 4 from the right? And that's where I told you about, let's take a look at this sign chart. So I'll start with 4 from the left. Let's go with 3.9. If I put in 3.9 into this equation up here, I'm going to get a negative number in the denominator because 3.9 minus 4 gives me a negative number. So in the denominator, I'm going to get a negative. In the numerator, I'm putting a 3.9 and I'm going to get a positive. What this tells me is that this guy right here is going to be negative infinity. Because if I keep adding nines, this number is going to keep getting larger and larger in that negative direction. So what this tells me is that the limit as x approaches 4 from the left is negative infinity. Now what I'm going to do is the same thing from the right. I'm going to go 4.1 here. Again, 4.1 in the numerator is going to give me a positive in the numerator. But now 4.1 in the denominator, 4.1 minus 4 is going to give me a positive in the denominator. This guy's actually going towards positive infinity. So this guy's limit is positive infinity. And because the limit as x approaches 4 of f of x does not exist, that's what infinity means, it does not exist, there is a vertical asymptote at x equals 4. That's how we prove it. So it's not because it made the denominator 0. Yeah, that's how we initially learned it. Now we're talking about limits. And I'm telling you, when it comes to the test, we got to go through this whole thing. So now we're going to go and do the same process. Now we're going to look for horizontal asymptotes. And again, I'm going to go over what I saw most commonly is using the Algebra 2 pre-calculus reason, which is great to learn it initially. But now that we're in AB Calc in this AP class, we actually have to prove a little different. So yes, I agree. The degrees are the same. The degrees are the same means it's a ratio of the top to the bottom. So I understand where people are coming from, that there's a potential horizontal asymptote at y equals 2. That is true, but it's not because the numerator and the denominator's degree is the same. What it is it's because of a limit again. And what that limit is the limit as x approaches infinity of this guy. And it's the limit of f of x as x approaches negative infinity. So what happens up top, what happens down below when I stick these really big numbers in? And there is a way that I can say that what we do is we actually kind of divide by the biggest term, and I can kind of walk through it in class. But the realistic way is, honestly, when all said and done, if I'm putting infinity in for x's, infinity squared is a huge number. Infinity big, but not as big as this squared version, and then 3. Really what I'm going to tell you is, these guys don't really kind of carry much value in the limit because they're getting larger at a smaller rate than the rest of the expression, the rest of the rational. So really what I'm looking at is, if I were to put an infinity and an infinity, look at this. I mean, basically, if you think about it, those almost in essence cancel out, if you will. What that's going to do is it's going to leave me a 2 over 1. What this happens is this limit, as I put in infinities here, infinity squared over infinity squared, in essence, just cancel out. That leaves me a 2. If I put negative infinity in, so I'm going to end up with, 2 times negative infinity squared over 1 times negative infinity squared. So again, in essence, these guys, divide out to 1, and it leaves me with a 2. And the reason that there is a horizontal asymptote there is because of this limit. It's not because the degrees are the same. That was just kind of the shorthand version. It's because of these two limits that the horizontal asymptote is at y equals 2. So that's kind of how the way we have to deal with those. So these are the first set of free response questions. I'm going to do another video that'll kind of talk about the second set of free response questions.